In this video, I want to talk about the route inspection problem, which is all about making nodes even so that we can travel along all the arcs of a network. So, I've just put some top tips on this first page here. The main aim of the game and the first part of the question is usually always to make every single node even, because you want to be able to start and finish anywhere on your network so you can travel any route you like. So that will involve duplicating some of the arcs, because the question itself will probably have, to begin with, 4 odd nodes, usually. But obviously you've got to check the question that you're doing. However, often then in part B or C, you'll be told that you're now allowed to start anywhere, or that you start at a particular place and finish at a particular place, and when you look more closely, it turns out those places you start and finish are odd nodes. Now remember, this means it's semi-Eulerian. You can still traverse it if you start at an odd node and finish at an odd node if there are no other odd nodes on that network. So that means you can have those two, but everything else needs to be even. But you're only doing that semi-Eulerian if you're explicitly told to. If it's just a normal route inspection problem, you're making absolutely everything even. Now, in the very last part of the question, you're usually given an additional complexity. You may be told, for example, that one of the roads is now closed, or you're told that someone wants to travel another route, or a road is added, or something like that. So then you've got to put your thinking hat on and think, how does this change what I've already done? You probably won't have to do the whole thing all over again. You just have to think really carefully about how that changes things. Does that make new things even? Does that make new things odd? How many odd nodes are you now left with, and how can you deal with that? Let's put those principles into practice on this question, which is May 2011, question 5. So first of all, the first thing that I always do whenever I see that it's a route inspection problem is I want to label every single node with its valency, so how many lines it's got coming out of it. That's the first thing I want to do, and make sure you do it accurately. If you have done it accurately, you should have an even number of odd nodes. So you should either have 2 or 4 or 6, etc. odd nodes. It's impossible to have an odd number of odd nodes. But in practice, you'll either have 2 or 4, probably 4 to make it a little bit trickier for you. I've now labelled every single node with its valency. I now need to pick out which ones are my odd nodes. So my odd nodes here are D, F, A, and C. I'm going to be looking for the 3 different combinations of those pairs of arcs so that I can join in 2 additional arcs to make all of those nodes even. If you've got 4 odd nodes, there are always going to be 3 combinations of ways that you could join those with arcs to make all of those nodes from odd into even. For example, if I did DF and AC, so I added in those 2 nodes from D to F, like that, and then one from A to C, like that, then all of those nodes would then be even. There are 3 different combinations which I worked out just by going that and that would leave that and that, then D to A would leave F and C, and then D to C would leave F and A. So I worked out those combinations as possible ones. Now, I want to find the shortest route around the whole thing. So I need to work out the lengths from going from one of these to the other. So the shortest way to go from D to F is probably going to be this route up here, which is going to be a length of 13. And my shortest route from A to C is going to be the direct route AC there, which is going to be 9. Now just be a little bit careful when you're doing these, because sometimes they do trick you and there is a shorter way that's like round another route rather than a direct one. You're always looking for the shortest way to get from one node to the other. I'm going to pause this and just stick in the rest for you so you don't have to watch me doing that, because this is quite straightforward. When I've put in all of those lengths, I then need to add up the totals of all of the 3 different options so that I can find the shortest one. So I have an option between, I could have 22, I could have 24, or I could have 24 again. Now remember, I want to add the smallest possible weight to my network to make it traversable. So I'm going to pick the top one, DF and AC. The final thing I need to do is actually interpret that answer in light of the question. It's asking us which pipes will need to be traversed twice. Now it's very tempting just to write out DF and AC, but that's not actually the correct answer, because if you look up here, there is no direct route from D to F. To do DF, what we actually did was we traversed this one and this one. So actually, the routes that need to be traversed twice are DG, GF, and AC. It's really important that we don't just write out DF and AC, because that won't get us the final marks. Next, we're going to look at part B, which asks us to find a possible shortest inspection route and give its length. So what I'm going to do is I'm actually going to add in to my picture the arcs that I've added. So I added in one from A to C, I added in one from G to D, and I added in one from G to F. Those ones are the ones that I'm going to have to traverse twice. Actually, I'm going to do the second part, give its length first, because I think that's easier. To give its length, all I'm looking at is the total length that is given me in the question, 98, plus the ones that I'm traversing twice, so plus 9, plus 13. And that's going to give me 120. The other part of the question just requires me to find an actual route which works. So to do that, I'm just going to experiment a little bit. I'm going to give it a go. I might go wrong, but let's try starting here and let's go like this. We'll go down here, round here, up there, up there, up there, up there. Okay, I'll just pause and record exactly what I did there. I did C, B, A, C. Then I did C, D, back to A, back to C. Okay, let's carry on going. I'm going to go up here, up, down here, up here, round there. Let's record what I've done so far. So I went from C to E to B, up to F, into E. Now I'm going to go up here, down there, round there. Let's record that. E, G, F, G. And then I'm going to go down to D, up to G, and down to C. So G, D, G, C. Now you might have to give that a go a few times in order to cover up every single arc, but it should work. In the final part of the question, I'm now being told that I want to start my inspection route at D, and I'm allowed to finish at any node. Now this goes back to what I was talking about at the beginning. Something's changed. Now we're starting here at this odd node, and we're allowed to finish anywhere. So we're allowed to finish at any odd node. This means I only need my graph to be semi-Eulerian. I only need to add in one arc so that I've still got two odd nodes left. I know I'm starting at D, but I've got three options for where I finish. I could either finish at A, C, or F, and all of those will have different implications. For example, if I finish at A, that means that A and D are allowed to be odd nodes. So the ones that I've then got to make even are F and C. Well, I can make those even just by joining them up. So I have to add in the arc FC. The similar applies for adding in FA if you're finishing at C, and adding in AC if you finish at F. The one that you don't finish at, or the two that you don't finish at, are the ones you have to make even. Because if you start and finish at a node, it's okay for those two nodes to be odd, but everything else in your network has to be even. So now I'm still trying to minimise the length of this route. So what I've got to consider is whether adding an FC, adding an FA, or adding an AC, which one of those is the shortest? Well, adding an FC is going to be a length of 8, because I can travel this route here. Adding in FA is going to be a length of 17, because I can travel 8 here plus 9, 17. Adding in AC is going to be a length of 9 because I can just travel directly there. Now I want to minimise the length of the route. So I want to choose this one. I want to choose to add in FC. That means therefore that I finish at A. Looking back at the question here, determine the finishing point. I'm going to say my finishing point is A. And this is my reason. My reason is that adding in FC gives my minimum additional weight that I have to add to the route. So I'll just write a quick sentence saying that. And then finally state the length of your choice. Well, that is just the length of the whole network, which is 98, plus the length that I've just added. So I'm doing 98 plus 8, which would give me 106 as my final weight for the whole thing.